So let's just see how we can create singly linked list. So the singly linked list is a linear data structure and it consists of nodes. So it can consist of multiple nodes and each node contains two parts. So it has the data part and the link to the next node. So first of all, we have one head pointer which is pointing to the first node, and then each node in the list contains a single link to the next node in the sequence. So this node is pointing to the next node. Similarly, this node also going to point to the next node. The last node will point to null, signifying that this is the end of the list. So because here we have only one link to the next node, so we cannot go back in the direction. So here the traversal can be possible in the forward direction only. So because of this, it is called the singly linked list. Now to create one node, we can use the structure, the struct node, and then inside the node we can have this data part. So we can create int data, and also we have this link. So the link is a struct node type. So we're gonna create this struct node pointer link. So this way we can define one single node using the structure. So first of all, let's just define one single node. So we're gonna use the structure, so struct node, and here inside we're gonna have the integer data, and then the struct node type pointer, we're gonna call this link. So we are done with defining one single node. So let's just see how we can create one linked list consisting of the data like 100, 200 and 300. So here we need to create three nodes and they will contain these three data. So first of all, here we're gonna create one head pointer. So struct node type pointer head. So this will be pointing to null. So that means we have created one head pointer and the pointer is currently pointing to null. Now we're gonna create those nodes one by one. So first of all, let's just create this node with the value 100. So to allocate the memory, we're gonna use the malloc, and here inside we're gonna pass size of struct node because we are allocating memory for one node. Now this will return one void pointer. So we're gonna typecast it to struct node pointer type, and our head node will be pointing to that newly allocated memory for the node. So that means we have created one new node using the malloc, and now the head is no longer pointing to null. Now this head pointer is pointing to this newly created node. Now we can put data into our newly created node. So here we can say head arrow data. So the data will be 100, and also we're gonna set head arrow link. So the link will be null. So this newly created node, we have stored the data as 100 and the link is currently pointing to null. So we are done with creating our first node. So let's now create the second node 200. So here also we're gonna use this malloc to create the new node. Now the thing is, we cannot use the head pointer to point to this new node. So here we have created the new node, but we cannot use this head pointer to point to this newly created node. If we do that, we're gonna lose link to this first node. So instead we can create another pointer. We're gonna call this current, and we can make the current to point to this newly created node. So let's just create another pointer, struct node type pointer current. So and the current will point to the newly created node. So now we're gonna store the data. So current arrow data. So the data will be 200 and the current arrow link will be null. So we have stored the data as 200 and the link is currently null. So we're done with creating this node with the data 200. Now we have to create the link between these two nodes. So to create the link, we can use head link equal current. So that means this is no longer null. So the head link is pointing to this newly created node. So let's now create another node where we're gonna store the value 300. So here also we're gonna use this malloc to allocate memory for another node. So that means we have created another node using the malloc. So first of all, we have to set the link between these two nodes. So because the current is pointing to this node, So we can use that. So here we can say that current arrow link is equal to this newly created node. That means the current link is no longer null. The link is pointing to this newly created node. So we're gonna move this current pointer to point to this newly created node. We're gonna move the current pointer, so current equal current arrow link. So we are moving our current pointer to this newly created node. So now we can set the data. So current arrow data is equal 300 and current arrow link, so the link will be null. So that means now we are storing the data as 300 and the link is currently null. So we have created 3 nodes with the value 100, 200 and 300, and also we have successfully set the link between these 3 nodes. Now to verify that, we can print the element of the linked list. So here we're gonna print the singly linked list. So we're gonna start from this head node and we have to loop through until we reach this last node where we have the link as null. So first of all we have to create one temporary variable. So struct node pointer temp. So the temporary variable will be pointing to the head. Now we're gonna use the temporary variable. As long as the temporary is not null, we're gonna continue that loop, and inside that we're gonna access the value of the linked list. So we're gonna use temporary arrow data. So we're gonna access the data and we're gonna print the data, and also we're gonna use one arrow so that the things will look really nice. And here we're gonna move the temporary pointer in every iteration. So temp equal temp arrow link. Let's now run this, and here we have the data. So first of all we have 100, then 200 and then 300. So this way we can create singly linked list where we can have multiple nodes and they are connected using the link between them. So hope you understand about singly linked list. See you in the next one. Take care.